In 2016, the European Southern Observatory reported finding an exoplanet that appears to be the closest to us. Proxima Centauri b, or Proxima b for short, is located in the habitable zone of the star Proxima Centauri. This means that there could be life on it. And if Earth suddenly finds itself on the brink of destruction, this exoplanet could become one of the best places to move to. Moreover, flying there would take just a little more than 4 light years, which is very close by space standards. But for our current technologies, this distance is really huge. In this video, you'll find out how far have people gone into space, what engine will make a spaceship fly 600 times faster than lightning, and when will our spacecraft be able to reach the new Earth? Why is it necessary to fly to Proxima b as fast as possible? This is the Centaurus constellation in the southern sky. At the knee of its front leg, there's the triple star system Alpha Centauri. Proxima Centauri is the smallest and closest to us. Right at this moment, it's moving along its huge orbit towards Earth at a speed of 22 kilometers per second. This is 3 times faster than the space shuttle moves. Now, we have the perfect opportunity to explore this promising exoplanet, because after this phase of the approach, it'll move 700 million kilometers further away from us every year. That's almost the distance from the Sun to Jupiter. If we're too late, potential colonization will be delayed by centuries or could become impossible altogether. Proxima Centauri is a red dwarf. Compared to our Sun, its diameter is 7 times smaller. It's also 8 times lighter, and its temperature half that of our Sun. Looks relatively modest, but you could settle down nearby. Besides, Proxima b is 20 times closer to its star than Earth is to our Sun. This proximity might lead to one side of the exoplanet being always turned towards its star, just like the Moon is to the Earth. That's why half the planet might be hot and the other half icy. However, some scientists don't see this as a problem. After all, if Proxima b has an atmosphere and oceans, they could ease extreme temperature changes. Given that this exoplanet is more massive than Earth, it could hold both air and water. An unpleasant surprise waiting for us is Proxima Centauri's rage outbursts. A red dwarf can suddenly become 1,000 times brighter from time to time, and if this happened, it would generously irradiate Proxima b. So both local life and colonists from Earth would have to take refuge on the planet's dark side. But to finally understand whether Proxima b is suitable for life or not, we need to check it in advance before it starts moving away from us. And considering the potential of contemporary spacecraft, that's a rather big problem. Why would existing spacecraft spend ages flying to Proxima b? To convey the scale of this task, let's put aside kilometers and get out our space tape measure. 1 astronomical unit, or AU, is the distance from the Sun to the Earth. That's around 150 million kilometers, and there are only 5 terrestrial spacecraft that have ever flown 10 times greater distances in space. The New Horizons probe was launched in 2006. With a speed of 15 kilometers per second, it's already managed to explore Pluto and its moons. At this moment, the probe has moved away from the Sun by roughly 50 astronomical units. At the same time, the twin probes Pioneer 10 and 11, which were launched by NASA in the early 70s, in their turn have achieved over 120 and 100 astronomical units. The Voyager 1 and Voyager 2 probes, launched in the late 70s, can be called record holders in this space marathon. Voyager 2 has already flown over 122 astronomical units, while its twin brother set a flight distance record over 147 astronomical units. And that's what the distance from Earth to Proxima b looks like compared to the achievements of our probes. And if the most advanced Voyager 1 decided to fly to Proxima b, it would have to overcome a distance 1,800 times greater, and it would take almost 74,000 years. To get there faster, we'd have to load our probe with fuel tanks to speed it up, which means there would be no room for for scientific equipment, and the meaning of the mission would be lost. So we need new engineering solutions. How soon can we get new engines for interstellar flights? Luckily for us, scientists have long been trying to solve problems with probe fuel. That's why they experiment with a lot of alternative energy sources. But will they have enough time to create a new fuel-powered engine while Proxima b is still moving towards Earth? Jim Woodward and Hal Fearn, physicists from California, are developing something called the Mega Drive, which applies Mach's principle. Sounds like a voodoo spell, but they hope this project will open the era of interstellar space travel. The Mega Drive creates vibrations and moves them in the needed direction with the help of electricity and a stack of crystals. It's kind of like shaking on skates from the cold, but directing your shiver forward so that its power pulls you towards a glass of hot mulled wine. Sounds incredible, but it must be very economical in practice. NASA's already provided money for development, but everything remains just at the level of theory so far, and you can't get very far with that. British engineer Roger Scheuer went even further and came up with the EM drive engine, which was immediately nicknamed the Impossible Drive. It consists of a magnetron that reflects microwaves just like in your ordinary microwave oven. They get trapped in a cone-shaped thing and generate a powerful thrust. That's an eco-friendly idea functioning on electricity alone. Unfortunately, it's not possible yet to say when exactly the first prototype will start working, which kind of justifies its nickname. To conquer Proxima b, we need something more reliable. And the thermonuclear engine project is showing outstanding results. It's being modeled at the Princeton Plasma Physics Laboratory. This engine will run on the nuclear fusion energy of helium-3 and deuterium. Spacecraft with such an engine could make it to Pluto in just 5 years. That's twice as fast as the New Horizons probe. And in 42,000 years, it would be able to reach Proxima b. Not that bad, but unfortunately, our window of opportunity will have slammed shut by that time. According to astronomers' calculations, Proxima Centauri and its exoplanet will begin to rapidly move away from us in their orbits in 27,000 years. And so far, there's only one technology that has a chance to deliver probes there in time. What do spacecraft capable of quickly flying to Proxima b look like? If we want to study the nearest star system not in thousands of years, but in the coming decades, the probe will need to speed up to 1/5 the speed of light. That's 60,000 kilometers per second. It's like circling the Earth 1.5 times every second. Yeah, that's pretty fast. So far, only the Breakthrough Starshot project could hypothetically do that. The idea is based on the fact that ordinary photons have impulse and can push objects they bump into. In a nutshell, if you put a solar sail in space, the light of our star or a laser will make it fly. First, a normal rocket will lift 1,000 probes into Earth's orbit, each weighing just 1 gram. That's lighter than a chip. Each probe will have a solar sail 4 by 4 meters in size, 100 nanometers thick, and weighing another half a chip. When the sails are installed, a 100 gigawatt Earth-based laser system will fire at them for 10 minutes. And this is enough for a fleet of microprobes to start flying at the very same 1/5 the speed of light. And that is 600 times faster than lightning. At this speed, a collision with even a speck of dust will destroy the sail. And those probes that would survive and reach Proxima b only 20 years later must do another trick that even the superhero Flash would envy. They'll only have a mere moment to take a photo of the exoplanet, as there's only one chance. The main thing, I suppose, is not to forget to remove the lens cap. After that, the photos will be transmitted to Earth, which would take about 5 more years to reach us. Today, engineers are striving for the launch of Starshot with all their might, so that here in this 21st century, we can finally say mission accomplished, that we've reached another star for the first time in history. But what will we see in the forthcoming images from Proxima b? Oceans and Earth-like atmosphere, or scorched desert? If Proxima b turns out not to be suitable for life, it's not the biggest deal. In the Alpha Centauri binary system, both stars have their own exoplanets, and from a base on Proxima Centauri, they'll be within reach. So we know indeed we'll find something interesting somewhere in the vicinity of Centaurus left knee. But if you want to know why we haven't found any aliens yet, check out this video. Here, I explain the Fermi paradox and dive into the many theories of how extraterrestrial life may be hiding from us.